Good day, everyone. Today we will be discussing about understanding correlation analysis. So we're done with basic concept of testing hypotheses. So this is another chapter in statistics and probability. This probably will be the last chapter in statistics and probability. So we will be discussing about understanding correlation analysis. So when are we going to use correlation analysis? So if you are going to find the relationship between two variables, or for example, you are in your practical research too, it implies that if your topic deals on relationship, wherein you're going to find the relationship between any variable or two variables, it implies that you're going to use correlation analysis. But let us first illustrate what is a correlation analysis. So for today's discussion, you will be able to illustrate the nature of bivariate data, construct a scatter plot, and describe the shape, trend, and variation based on a scatter plot. Let us differentiate first a univariate from a bivariate data. Once you said univariate data, the examples are grades of students, weights of grocery products, lengths of rods. However, if we're going to deal with bivariate data, examples are final grades in mathematics and science, attitude of students in school, and house. So as you can see, we're going to take a look on the examples of univariate data and bivariate data. We can say that once it's a univariate data, it implies or it deals only for one variable. However, if we're dealing with a bivariate data, we're dealing with two variables. Now, the relationship between two variables is described in terms of strength and direction. This is an illustration of relationship between two quantities representing for the direction. So as you can see for negative, as x, you already know that this is the x-axis and this is the y-axis. So as x increases, the value of y decreases. So if that happens, the x increases, if the x increases and the value of y decreases, it implies that you have a negative correlation between two variables. Like for instance, this one, the auto value and auto mileage. So if the auto value increases, the auto mileage decreases. For zero, as you can see, the points are scattered. As you can see, the points are scattered. There are no direction, or there is no direction, as you can see on the given scalar plot. That implies that the auto body color and auto quality has zero correlation. It implies there is no correlation at all. However, on the other one, as you can see, as the value of x increases, this one, the value of y increases also. So, as you can see, as the auto insurance cost increases, it implies that auto accidents also increases. So, thus it implies that you have a positive correlation. So please take note of these three. Correlation in terms of direction. So we have negative. As the value of x increases, the value of y decreases. For zero, the points are scattered. No direction is illustrated on the given scatter plot. However, the last one is positive. If the value of x increases, the value of y also increases. Now, on the other hand, we also have the correlation according to direction and strength. We have perfect positive correlation. We can have perfect positive correlation if you can form a straight line wherein it goes upward. However, if there is simply a simple scattered but you still see a direction positively, it implies that your correlation is high positive correlation. So take a look on the difference between the two. On the perfect positive correlation, it forms a straight line. However, for high positive correlation, you can see a straight line. However, there are a little scattered point on this illustration. We also have low positive correlation. It will be low positive correlation wherein you can see a straight line. However, there are some points that are scattered. Unlike with high positive correlation, just a little points that are scattered. However, here, there are some. Medyo madami yung mas scattered, but you can still see the straight line. There will be no correlation if the points are scattered and you cannot see any direction with this scatter plot. Then, you can have low negative correlation if you have a straight line going downward. However, there are points that some points or medyo madami yung points that are scattered. However, for high negative correlation, there is straight line. However, there are just only little points that are scattered. Still, you can see or figure out the line going downward. And you can have perfect negative correlation if you can see a straight line. No points are being scattered. So this is just only a representation of correlation according to direction and strength. So please take note of this because we will be using this as we go on with our example. Let's now plot the points on a Cartesian plane. This deals on the relationship between the study habits and grade point average in science of grade 9 students. So let's first plot the study habits. So as you can see, it involves 0 to 5. So let's now have, so for x value, let's have this one. For x, we have 0, 1, 2, 3, 4, and then 5. And then for GPA in science, this is for y values. So this is the y-axis. We have 75 to 94. So we can start here with 75, 80, 85, 90, and then 95. After having this one, we can now plot the points so that we can now create a scatter plot of the given data that we have. So we have 590. So again, we have 590. So let's now plot 590. Next, we have, sorry, it's not on 5. It's 590. Next, we have 494. So 494 will fall here. Then we have 385. 385 here. We have 488. 488 will fall here, maybe here. Next, we have 592. 592. So it it falls here. Next is 384. So we have 384. Next is 280. 275. And then we have 381. So maybe it falls here. So here is the scatter plot of the given data pertaining for the relationship between the study habits and GPA in science of grade 9 students. So as we take a look on the illustration of our scatter plot, the points are going upward. Since the points are going upward, it implies the direction is positive. Now let's take a look on the strength. Is it low, high, or perfect? So it's not perfect because as you can see, there are points that is being scattered. But we can say that it is high. That's the reason why we can say that the relationship between the two is positive high correlation. So we have positive or high positive correlation. So we have positive high correlation or high positive correlation. We have this. So the answer for this one is positive high correlation. Let's try another example. The following data show the attitude scores and mathematics achievement of a group of students. So now we're dealing with the attitude scores and mathematics achievement of group of students. So let's now check. This is the data. Attitude score and achievement in mathematics. So let's now have for X, we have from 41 to 48. So let's now have 0, then 41, okay, Okay, let's continue. 42, 43, up to 48. So 44, 45, 46, 47, and then 48. For achievement in mathematics, since that is y, so automatic it will fall on y-axis. So as you can see, the lowest number is 17 and the highest number is 22. So let's now have 17, 18, 19, 20, 21, and then 22. Let us now plot the points so that we can now draw a scatter plot, or we can now create a scatter plot. So let's start with the upper one, the 48, 22. So we have 48, 22. Next is 48, 19. And then next we have 47, 20. Next is 46, 20. Next is 46, 17. Next is 43, 21. Next is 42, 21. And the last one is 42, 9. I'm so sorry. It's 42, 21. We're done with 42, 21. We're not done with 42, 21. And then next is 42, 19. And the last one is 41, 17. So as you can see, we can still see the pattern. The point is from going upward. As you can see, the points is going upward. However, the points are still scattered. Since it is going upward, automatically we have positive. However, since the points are very scattered, but still we can see the trend of the line, of the points rather, so it may be low. So that's the reason why we have positive low correlation with this one. Okay, so let's now have another example. The following data show the let results and teacher's performance rating. First, we need to construct a scatter plot for the given data and then describe the relationship between let results and teacher's performance rating in terms of direction and strength. Let us now have, this is the data. Let's now have the scatter. Okay, here is the data, let results and teacher's performance rating. So let's start with let results X. It starts with 76 up to 85. So we have 76, 77, 78, 79, 80, 81, 82, 83, 84, and 85. For teacher's performance rating for Y, we have 4.2 as the lowest and 4.75 as the highest. So we can start with 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, and then 4.8. Now let's plot the following points so that we can create a scatter plot. 77, 4.20. 76, 4.35. 70, 79, 4.5. So we have we're done with 76, 4.35. 83, 4.60. So we have 85, 4.75. 79, 4.55. It will fall here. 77, 4.20. Again, here. 80, 4.70 will fall here. 84.55. Here, so we're done with plotting the points and we already created a scatter plot. So as you can see, the trend of the point is going upward. So automatically have positive correlation. Now, as you can see, it's not perfect because there's still points that um, scattered with the given trend. That's the reason why we can say that since hindi masyadong scattered yung mga points natin, automatic can say that it is positive high correlation. So therefore, the relationship is positive high correlation based on our scatter plot. So that's all. Thank you. I hope you've learned a lot for today's discussion. Please don't forget to subscribe on our channel. Hit the notification bell button so that you will be updated with our video tutorials. Thank you and God bless.